So continuing here, let's do some more limits. All right, limit as x approaches negative infinity, 6x squared over x plus 3. So this is where we want to weigh the numerator and denominator here. I do have the higher power in the numerator. Means it's going to dominate. It's going to go to a type of infinity. But, so let's do sign accounting. Minus infinity we're going to, but the x squared here is going to make all of that positive, and the 6 isn't going to change that. But these x's down here are going to be negative, so overall I'm going to get a negative infinity. Okay, so what's happening here in this one? Limit as x approaches infinity of 1 over 2x plus sine x. Well, I really just have a constant on the top. Then I have this 2x term and the sine x term. So this 2x term is going to go off to infinity as x goes to infinity. This sine term is going to oscillate, but it's not going to be able to stop. It's not going to be able to stop this 2x from going off to infinity. Let me make that more clear. And so basically I have a constant over something going to infinity, that's 0. Okay. Now we go limit x goes to negative infinity 1/2 x. Okay, well that's going to go to negative infinity. And then the 4 over x squared, well if the x squared is going to, if the x is going negative infinity, the x squared is going to go to infinity. And then this constant over infinity, this whole thing is going to go to 0. So I get negative infinity minus stuff going to 0, negative infinity. All right, so now let's take a look at this one here, where we're going to sketch the graph of a function with all these properties. Okay, good problem here. All right, so let me set up an axis. And let's try and just make sure that we incorporate all this stuff in here. All right, so let's start here. Limit x approaches 2 of f of x is negative infinity. That means that as I approach x2 from either direction, before it or after it, right or left, I get negative infinity. Well, that's telling me there's a vertical asymptote at 2. So let's put 2 here. All right, and so I have a vertical asymptote there. Okay, what else? X approaches 0 from the right, I get infinity. All right. Oh, so I should have, sorry, in the first one with 2, it was telling me I'm going negative infinity. So basically, I know that I have that, and let me get that VA out of the way there. And that. All right, so those things I got from this first statement. So as I approach 0 from the right, I go off to infinity. So as I approach 0, I go off to infinity. Okay. As I approach 0 from the left, I go to negative infinity. So that just means I'd be doing something like that over there. As I approach infinity, I get infinity. Okay. So that means as I head out here, I have to go off to infinity. So I'll just make it, go off to infinity. So this was that part. And then as I go to negative infinity, it goes to 0. That's actually telling me I have a horizontal asymptote at y equals 0. So what I could do is, lots of different things I could do, but I could just curl this thing up like that and go to 0. So there I've actually put in all these pieces. That is what's ensuring that everything is met in there. Now I could do anything else I wanted in between. I'll just make it pretty simple and just, connect that up like this, I could do something like that, and then I could do something like that. Okay, but I could have done a lot more. So this is one possibility. But I could have done plenty of other stuff. And so, what I could have done, whoops, I could have in here, it wouldn't really matter if I, wanted to go, whoops, I didn't mean to do that. If I wanted to say, come down here, go back up and down like that, that'd still be the same. There's nothing in the information that makes that not a right answer. But I'm going to go back to my original one there. Okay, there we go.